workshop on Internet and Big Data Finance. I will be presenting on the topic a Big Data Analytical Framework for Portfolio Optimization. This is the flow of my presentation. First, I will give you a basic introduction on Big Data and its importance in capital market, followed by the gaps identified from the previous work, from which we have derived our objective, then the proposed framework, followed by expected outcomes and conclusion. We all know that big data has become a buzzword in recent years. First, let's understand what big data is. Big data refers to a huge size of unstructured data produced from various applications like social media till the scientific computing devices. And the data set ranges from few hundred gigabytes to zettabytes, and which is beyond the capacity of the existing data management tool to capture, store, manage and analyze. And big data can be characterized by few dimensions. First, let's talk about volume. Volume, as the name suggests, refers to the huge size of data that is being produced. According to International Data Corporation, the amount of data that would be generated between 2012 and 2020 would be 35 trillion gigabytes, which is like 1 gigabyte is equal to 2 music CDs. So in physical sense, the amount of data produced would be equal to the number of stars in the physical universe. And second is the velocity. Velocity refers to the speed at which the data is being generated. The data is generated at, we can see it in at the frequency of weekly data, ya daily data, ya hourly data. This is due to the availability of internet on mobile, laptops, smartphones and etc. The third dimension is the variety. Variety refers to the data like structured data and unstructured data. Unstructured data refers to the data which can be stored in some relational table like that. And the unstructured data refers to data which cannot be stored in the relational table form, which refers to text, images, log file, videos, etc. And the other dimensions are variability. Variability refers to the different locations that have different semantics, because different semantics means that people from one location would mean something, the other location would mean something. The language difference over location is captured in variability. The complexity. Complexity refers to the type of data that is being stored. Transactional data would require different type of storage and analysis, and the log files would require different type of analysis and storage. The last dimension is the low value density. Low value density refers to the data in current form cannot be used, because like if you take log files, you want to analyze something on customer behavior. You cannot directly use log file and explain what is the consumer behavior. You need to analyze, then you have to interpret and tell. And we all know that big data technologies is in use in other fields like market analytics, consumer analytics, telecom analytics. Now big data technologies are being used in capital firms as well. In capital firms, they are used for trading analytics and for risk mitigation and for capturing the fraud in credit card assessment, etc. And one of the next big challenges for capital market is to handle the velocity of big data being produced. This is due to the different types of capital market data that is being generated. There are 4 types of capital market data. First is the reference data, which refers to the exchange or the ticker symbols and the stock price and all. And the fundamental data refers to the corporate financial reports, etc. And the third is the news. We all know that like people generally refer to so many business news or economics news, and they also form part of capital market data. Last is the social media, where we capture the market sentiment. And this slide is just a recap of portfolio optimization. First, let's understand what portfolio is. Portfolio refers to a collection of assets. Asset could range from stock, bond to capital to real estate. And portfolio optimization. Portfolio optimization is the process of making investment decision on holding a set of financial assets to meet various criteria. The two general criteria of portfolio optimization is to minimize risk and to maximize return. Let's understand what these criteria mean. Suppose if I am a risk taker investor, I would like to invest in stocks where there is a high risk, and I generally high risk would mean that we have high return. Suppose if there is someone who is averse to risk, that is like a pensioner or people who are retired, they generally don't want to take risk at the age of 60 or something. So they would like to invest in bonds where there is high security. They know that they have a constant return and the risk of not getting return is minimized. And there are three major steps of portfolio optimization. First is the asset selection. In asset selection, we decide in which asset we need to invest in. For example, as an investor, I can decide whether I want to invest in bond, or I want to invest in real estate, or I want to invest in stock. Suppose if I have decided that I have to invest in stock, I will decide in which sector I would like to invest in. Whether I would like to invest in automotive sector, where the probability of risk is high, because during recession the manufacturing of automobile decreases or the sales of automobile decreases, which would again reflect in the stock price. So I know that it is a risky zone. Or whether I would like to invest in FMCG, where the growth will be there even during economic downtime. And second is the asset weighing. In asset weighing, I would decide how much I would like to invest in each stock. Suppose I have decided I will invest in a stock of automotive sector, and I would like to invest in stock of FMCG. So I have, let's assume I have 1,000 rupees. So I would decide whether I should invest all 1,000 in FMCG, or should I divide it between these two. If at all I am dividing between FMCG and automotive stock, I will decide how much to be invested in automotive and how much to be invested in FMCG. In FMCG, I would like to invest 800 rupees, and in automotive, I would like to invest only 200 rupees. So this is asset weighing. Now last step is the asset management, where I know that like based on other prediction and everything, I would like to know, okay, the stock of automotive is going to, the stock price is going to decrease. So now I would decide whether I should sell the stock or I have to buy a stock. When I know the stock price is going to increase, now I know this is the best time to sell the stock, so that I will get the maximum return. Suppose if I know the stock price is going to decrease, I will get the stock at the lower rate and I will sell it when the stock price is going to increase. This is asset management. And as I have told before, the stock range from stocks, bonds to real estate. I have limited the scope only to stock analysis. And this slide tells about our previous work, which we have classified into 4 different themes. First theme is the prediction of stock prices using social media and news articles. We all know that the news article or any event could affect the stock prices. For example, if I consider the case of India, the prediction that Modi will become the Prime Minister itself increased our stock price index. So these things affect the mindset of the investor. Second is the portfolio optimization using data mining approaches. Data mining approaches range from association rule mining, decision tree, artificial neural network, etc. People have used for stock prediction as well, and they have used for portfolio optimization also. And third is the portfolio optimization using heuristics. Heuristics, people have used like particle swarm optimization, ant colony optimization, genetic algorithm, etc. fourth is the use of quantitative data for portfolio optimization. Here the quantitative data refers to the ratio analysis which have been widely used by researchers for portfolio optimization. And based on those previous work, we have come to the following two gaps. To the knowledge of the authors, none of the framework considers both structured data and unstructured data. Structured data would refer to the stock price and everything, and unstructured data refers to the report or the news item, etc. And as I have already mentioned, only quantitative data is used for fundamental analysis. And so the objective of our work is to propose a framework that considers both stock price as well as the current affairs data to help the investors to make an informed investment decision. And to achieve our objective, we have formulated a framework that consists of 5-stage process. First is the selection of stock, second is the validation of stock, third stock clustering, fourth stock ranking, and fifth is the optimization. And I'll explain all these procedure in the following slide. And this is the framework, like pictorial representation of our framework. First, these two blocks refer to the first stage, which is the stock selection. Stock selection is generally referring to selection of stock that is profitable. So we are using data envelopment analysis. And these three blocks refer to the second stage, which is the stock validation. And this complements the previous stage. Here we are using the tweets and news article to get the current information about the company, and we'll collate all these information, and we use sentiment analysis to validate the efficient firms. This is our third step, which is clustering. Once we obtain the validated firms, we are clustering them into different clusters in order to minimize our risk. And this is the fourth step, which is the ranking of the stocks within the cluster. And the final step is the optimization, in which we decide how much to be invested in which stock. And here in all these steps, the previous output of the previous step would form the input of the next step. Here the efficient firms form the input of this, and the validated firms would form the input of this third step, and etc. And this is my first stage. First stage is the selection of stock. Here we are achieving the process using data envelopment analysis. Data envelopment analysis refer to is a non-parametric linear programming in which we calculate the efficient score of decision making unit using a set of input parameters and output parameters. And the firms with the efficient score of 1 is considered to be the optimal one. For example, if I take the case of manufacturing industry, in order to calculate the efficiency, we need a set of input factors and output factors. And what would be my decision making units? Suppose I consider Tata Motors or Hero Honda or Maruti. These would form my decision making units, and the input parameters could be like the number of hours the employees they put in, the amount of raw materials they use, and the output could be productivity. So in order to calculate the efficiency, I have the set of input parameters and I have the set of output parameters. Now I'll use DEA to analyze which all company are performing better. So when I use DEA, suppose if I say ki Tata Motors is having a score of 1, they are considered to be efficient, and the remaining two firms are not efficient. So in similar way, this method can be applied for stock selection. So here the DMUs would be the listed firms in a particular stock exchange. And as I already told, we are using data envelopment analysis, and input parameters for data envelopment analysis would be total asset, total equity, cost of sales and operating expenses. And net sales and net income would be the output parameters. The stock with a score of 1 are considered to be efficient and they are the output of this particular stage. And second stage is the validation of stocks, in which I am taking the tweets and news articles of the efficient firm. So this step basically complements the previous step. And why this step is necessary? Because as I have already told, the previous step considers only the quantitative data of the fundamental analysis. Fundamental analysis have two parts. One is the quantitative data and second is the qualitative data analysis. In quantitative data analysis basically deals with the ratio analysis. In qualitative analysis we consider the management of the firm and the current position of the firm. In management it would deal with the people who are managing, like the top management people, and the process would mean how much they are involved in R&D, what are their future plans. These all would affect the overall performance of the company, and it would influence the investors to decide whether they need to invest in a particular stock or not. So this is why we are going for this particular step. And the methodology I would be adopting is sentiment analysis using distributed text mining. Why we are using distributed text mining? Because we have a huge set of unstructured data and this would require a lot of processing. So we are going for distributed text mining, and I would be requiring the software framework of Hadoop MapReduce, and which have the properties which support the distributed text mining. And the properties are ease of use, scalability and failover properties. And this is an example to show that the effect of management on stock prices. This is an example of Infosys. Infosys is the third largest software provider in India as per 2014 revenue. And in 2010, the CEO of Infosys then was Narayanan Murthy, and who left Infosys. Basically he retired and he became a chairman emeritus. So after that there were so many problems in Infosys, so he rejoined in 2013, and this is the effect of top management people leaving Infosys after he joined. This refers to the exit of Basap Pradhan, the group head of sales and marketing at Infosys. This is July 2013, and after that you can see that none of the management people they left and the stock price is increasing. These all again refers to the exit of so many other top management people, and again there is nothing, like there is no confusion in the management and everything. The stock price is still rising, or at least it's maintaining its level. And here again you are following the same trend. And this is March 2014, where Infosys senior vice president quit, and after that the stock price fell to a huge extent. And this is the latest one. On April 18th, chief compliance officer, he quit, and this is till May. And on May 16th, the election results were announced, where Modi was elected as the Prime Minister of India. And based on how the market performed, the stock price of the stock index of Infosys should have been in the levels of 4,000, but it is not the case. The investors who were actually very happy when Narayanan Murthy joined back in 2013 are now worried because the stock price is falling down. This is just an example to depict why this step is necessary. And this is the whole framework of the second stage, where C1 refers to the news article of company 1, C2 refers to the tweets of company 2. In similar way, I am collecting the tweets and news article of all the companies, which is processed through multiple map processor, and I get the intermediate data, which consists of all partial result, and through map processor I aggregate the total result. At the end of this, I'll be having the market sentiment of all these companies. And this is my third step. In third step, now from the previous step we have come to the validated firms. See, at the end of stage 2, the sample size actually reduces. For example, if you take the listed firms in a particular stock exchange to be 1000, at the end of stage 1, after the quantitative analysis, probably the number of firms reduced to 500, and at the end of stage 2, the number of firms would have been 200, because we are validating whether only the quantitative data is required or even the qualitative data is required. Probably based on market sentiment and everything, the sample size is reducing to 200. Here we are taking those 200 firms and we are clustering them into different groups. And this step is necessary in order to reduce the risk of the investors. Suppose you have a basket and you have 10 eggs. You cannot put all the 10 eggs in one basket. Suppose if there is a hole in that particular basket, all your eggs would be gone. So it is advisable to put all your eggs in different baskets. So the same case applies here. You cannot invest in one particular group of firms. So you have to invest in different firms, like I said, FMCG or automotive and everything. So here we are having different clusters for that. So in this process, I will be calculating the correlation coefficient of returns of those 200 stocks, and I will be using clustering algorithm like K-means algorithm or Lovian algorithm. In K-means algorithm, the sample size would be distributed in different clusters based on their closeness of the mean, and in order to have a particular number and quality of clusters, we need to maximize the similarity within the cluster, and we have to minimize the similarity between the clusters. This step actually helps in the risk diversification. And this is the fourth stage, which is the stock ranking. In stock ranking, we have to rank the stocks in the particular cluster. Suppose in previous step I got some 10 clusters. I have to rank in each cluster the number of firms would be different, and we have to rank those firms within the cluster so that we select the appropriate stocks from each cluster, for which I would be using artificial neural network, which consists of 3 layers: input layer, hidden layer and output layer. And ANN can be modeled in 2 different ways, either the forward feedback mechanism or back propagation method. The commonly used methodology is back propagation method, and the input parameters would be GDP growth rate, interest rate, and the output parameter would be future return on investment. And last stage is the optimization. The general case would be to assume we would select the top performing stocks from each cluster. That may not be the case. Even then, if we know, okay, we are selecting the top 1 or top 2 from each cluster, we need to know how much should be invested in each stock. So we are using optimization heuristics like PSO and colony optimization, and we give the investors the top 3 suggestions which would suit their risk profile. And this slide tells about the expected outcome. These 4 stages would deal with the asset selection of portfolio optimization, and this stage would tell us about the asset weighing of the portfolio optimization. In this framework, we haven't considered the asset management part. At the end of stage 1, we come to a stage where we have a set of profitable stocks, and in validation of stocks, we are considering the qualitative data, which is complementing the first stage. And the stage 3 would help in the diversification of risk, and the stage 4 would help in the selection of appropriate stocks, and the stage 5 would give us the top 3 suggestions to the investors. And this is my concluding slide. The advantage of this framework is that it helps in giving investment decision to both naive investors and to well-informed decision makers, and it considers both structured data and unstructured data. In the sense, it considers both qualitative and quantitative part of fundamental analysis. It gives flexibility to the investors because they can select one of those 3 suggestions, or if we give top 5 also, they can consider these suggestions which suit their risk profile. And this framework can be applied to any stock exchange like New York Stock Exchange, Bombay Stock Exchange, or National Stock Exchange. The limitation of this particular framework is that it is limited only to stock analysis, and as I said previously, the asset management is not considered, and the future work is to implement this framework in NSE or in BSE, and these are the references I have used. Thank you for your kind patience.